Have you ever wondered what the real difference is between the authentic commercial video projection technologies versus what we have today at home? I mean, today it is closer than ever, and we get glorious picture quality at home through Ultra Blu-ray and another of other standards which are coming out. In this next video, I go really deep into the technologies with a team that build for both commercial projection, highest standard around, and also for the home game. So these guys know better than anyone. We discuss the challenges and the elements that actually drive the very best picture quality projection systems in the world. That's all coming right up. Hey folks, welcome back to another episode of Rogue from Reality, the channel where we focus on professional real cinema in your very own home. This is a super cool episode. I know you guys have already caught me talking a lot about audio already, but the big one today is video. It's only, or at least 50% of the cinematic experience, and our video and audio file guys can find out exactly where all that sits. Though I'm really blessed to be talking to a brand and representatives of a brand that is really dedicated in the residential space, as well as doing some phenomenal heavyweight products in the commercial, military side. And, you know, residential isn't always given the same focus and respect. And these guys are all about that. So really proud to have on board Andy Jones and Bart Devos from Barco Residential. Welcome, guys.
Thank you very much.
So you guys look after the business development and the sales section of a good half of the world, my region, Australia, Asia Pacific, and Europe as well. So helping to direct and understand what the residential market need and want, which is somewhat different to Barco's other roles out there. Now, Bart, I know you've been with Barco actually before Barco Residential really took a major grip and they started focusing in this space. Can you tell us a little bit more about the origin of Barco? And I know you guys got a great little origin story video as well on YouTube, so I'm going to add that to the link. People can learn some more, but please share.
Yeah, thank you, Scott. I mean, it's actually pretty interesting if you look at the history of Barco. I mean, we've been around since 1934, so that's a pretty long time that we've been in existence. And the funny thing is, whilst we're talking right now about Barco Residential and having that touch point with the consumer electronics space, it's nice to, if you look back at the origins, we actually started out in consumer electronics. Yeah. We were manufacturing radios at the start using American-made components, which is what gave the name to the company. So Belgian American Radio Corporation, BARCO, and then you have Barco. And then through the years, we evolved and we morphed into a purely B2B, business-to-business type of company, which we are today, with three main divisions being enterprise, entertainment, and healthcare. And then indeed, like you said, a couple of years ago, we started up that Barco Residential activity, focusing on high-end home theaters and high-performing media rooms. So that's where we have that touch point again with the consumer electronics. And then, awesome. Yeah, and then personally speaking, I mean, like I said, indeed, I've been with Barco since 2007, so quite a long time. In a previous role, I was in procurement, and over those years, you know, got in touch with basically all the different divisions within Barco, different technologies involved in, you know, product or component selection, close cooperation with R&D and our product management to try and find out and select the best possible components for the given products that we were designing.
So you get to go shopping for all the cool parts.
We get to go shopping for the cool parts, indeed.
That's amazing. So our main focus on this chat is going to be actually about what is the differences actually, because it's become, you know, home cinema's really got a whole lot better in the last 10 years in particular. And sort of seeing what the difference is now between, you know, real true commercial cinema versus home cinema. We are very close, but maybe not all the way there yet. But the fact is that we've got a lot of commercial level quality and studio quality attributes happening at home, which is really exciting. And hence, I think the success of where Barco is now, and I've personally delivered quite a number over the last year. And when people see the quality and understand not just the quality of the picture, but the quality of the build and the platform longevity, the ROI, the return on investment in getting to such a product is really big, because we're not poking in a DVD or a VHS anymore. We actually get something out the other side of a beautiful projection product. So, Andy, maybe you could share a little bit about just what the Barco projectors in particular are doing, because these are really of the highest spec home cinema projectors on the market, and where they sort of maybe differ with commercial projection. Maybe actually the audience might like to know what commercial or DCI projection is, so when we can start to see where this gap is and see how close we get.
Yeah, of course. So for me, I always liken it to, there are three grades of residential or consumer projectors. You've got your more run-of-the-mill consumer grade products, then what I would call the Barco Residential entry-level, perhaps more prosumer products, so derived from the commercial world. And then we've got DCI specification products, which truly derive from commercial cinema, but are tailored specifically for the residential market. So our prosumer products, for example, are derived from various different markets, which we then tailor specifically for the residential market, including technologies such as Cinemascope output in 5K resolution to provide that 2.37 to 1 aspect ratio, but don't offer DCI specification. So really for those, we're still looking at playing back UHD Blu-ray disc or streaming Netflix content, etc. And then our commercial theatre derived products have the ability to play DCPs, so digital cinema packages, which is the same content that's delivered to a commercial cinema, which has much higher bit rates, much higher quality video and audio. But as well as being able to play those, also providing us still the ability to be able to play our UHD Blu-ray, our stream content, our Xbox, but at a much higher quality level than even our prosumer products are capable of.
Yeah, right. So if we look at the top there, then a straight up dedicated commercial projector, it's only going to really accept the DCI feed in and out. Everything's very rigid and fixed and does its job. Whereas in the residential world, you still got to manage 720p, you got to manage UHD, you got to manage all different color spaces, frame rates, and then in the top models also DCI. So there's actually a lot more going on in a DCI spec residential projector than maybe just a DCI projector. Is that a fair call?
Yeah, very much so. Very much so. I mean, also we do a lot of things to optimize image quality for the residential space too, because on the commercial side, we're talking, maybe 20-foot to 50-foot screens, sometimes even larger. So of course, those projectors need a lot of horsepower and light output to really get the light levels and the image levels required on that scale. In the residential sector, we're obviously looking at much smaller screens comparatively, which means we can tailor the projector more specifically to those needs by perhaps sacrificing some of the light output capabilities of the projector and improving our contrast levels, for example.
Yep.
So we really tackle it at the approach of, taking a consumer grade product and all of the attributes it has, analyzing what the residential market needs. So, like we've already said, the ability to be able to play back consumer grade content, because at the end of the day, the customers that have our Thors and our Prometheus projectors, probably 90% of the content, if not more, that they play is, UHD Blu-ray disc, etc. And then on those special occasions, they play their DCP content, whilst ensuring that, the image quality is designed for that smaller format screen.
Yeah, cool. So a few things in that. Obviously, been able to fine tune for the smaller screen. So I guess you've got some headroom based on how you usually do things, which is just share output, light output for massive screens, massive audiences. So that's giving you, like, in contrast, of course, is magic. So we'll touch on that as we maybe pull apart what are the fundamentals of great picture, which, you know, is resolution, it's dynamics, it's color space, sort of frame rate, I guess, are the big movers and shakers of and these also what color shades. What do we call that one? Bit depth.
Yes.
General color accuracy and uniformity across the screen as well.
Yeah. So it's sort of the five big things that took us from HD video to UHD. So how you guys sort of tackle that, what you're delivering. But just for the folks listening as well, DCP content, what does that stand for and where does that come from? That's not so easy to get our hands on.
Yeah, of course. So it's a digital cinema package, which is the content delivered to a commercial cinema, which is obviously the video and the audio file together. And it's what the projector accepts in as a video and audio signal. So it's an encrypted package to obviously prevent people pirating it, etc., at a much higher quality rate than our standard consumer products. So to give you an idea, a DCP package in 2K format, which a lot of cinemas still use,
yes,
and the bit rate for that is typically around 250 megabits a second. 250 megabits a second. And
wow.
A 4K version of that will be almost double, so 500. Whereas if we compare that to a UHD Blu-ray disc, we're around 108, 110 megabits a second.
Mm-hmm.
So quite a difference in the file sizes that we're talking at there. And so we can deliver that sort of content to the residential market via products such as Bel Air Cinema, who specialize in that area and have licenses with the film studios to be able to provide that content, because it's not the content that you can walk down to your local store or hop online and just purchase, of course.
Yeah, so very protected. You got to sort of join the club to particularly get, premiere events, but that's all possible, right? Like you could watch the latest Christopher Nolan film. I'm not sure what that is. I'm a big fan, so surely there's another one coming up. The moment it releases live in, LA and Hollywood, you could watch that at home on your DC digital cinema capable system, right? With the right hardware.
Exactly. Normally there's a theatrical release window of around 12 weeks. And depending on the license agreements, which are often done studio by studio, but also movie by movie, you can watch that from day one of release often through to the 12 weeks. And depending on where in that release window you wish to watch it, you would pay a different fee, of course. So if you want to be right up to date and watch it day one, you would pay the big bucks. And if you want to watch it in week 12, it's still going to cost you a pretty penny, but comparatively less.
Wow. Okay, cool. So you can, I think for some folks, they may not realize that is actually even a possibility. Though we are talking, $100,000 for a player, we're talking 10,000 or so bucks for membership, I think, and we're talking maybe $500 to $1,000+ depending on the movie and when you want to watch it. So this is no $5.99 iTunes special, though we're getting 250 plus megabits of data streaming through the sucker. It's like double ever new HD content. So the difference there being, I guess, really compression, right? Like it's the typical CD quality versus MP3. That's sort of what's happening here, right?
Exactly, pretty much that. Yeah, it's almost for me likening watching streamed content against UHD, UHD Blu-ray. The streamed content can be very, very good, but if you do a side-by-side comparison, you start to notice the audio flaws, perhaps banding in, colors and what have you. And it's the same sort of difference as you migrate up to digital cinema packages. It's those subtle differences, but those subtle differences that make overall a really big difference.
I guess because really when you view an image, you're consciously aware of so much, but then you're unconsciously absorbing information as well. Our reticular activating system filters out so much. So when you can add that extra layer of detail and texture and reality to a picture, then, you're starting to get into a whole other experience of picture as well, which I've lucky to have seen. My reference picture is IMAX in Melbourne. It's one of the biggest. I think it's actually the biggest IMAX in the world. It's like 38 meters wide. And I believe, I'm not sure exactly the spec in there, but I think they got twin of their big RGB laser projectors running over the top of each other just to light, like the most powerful projectors in the world. Two of them doubled up to get some major light output off the screen. And I watched, Blade Runner there. I watched the 1917, and that was spectacular. Like just how rich the color is and the detail there was absolutely beautiful. So yeah, you certainly don't always know what you're missing out on until you kind of go, oh, hang on, there's another layer.
Yeah.
Which is exciting. Actually, as I touched on the IMAX ones, they're running three, I believe it's the laser system, so red, blue, green lasers as a light source. Is it true that Barco are actually some of the team behind helping IMAX develop that level of projection system?
Well, I would say that indeed it's a co-development. So we provide the light engine portion of those systems, and then indeed IMAX incorporates their own proprietary technology to assemble what then results in the overall IMAX experience. So yeah, indeed we're a part of that, and we're glad to be a part of that.
Wow, that's mega. Because I know I'm not sure what Dolby Vision Cinema is exactly all about, and who they partner with there. I know there's a few in America. I don't believe there's any in Australia, so hence I go back to Melbourne all the time for my IMAX goodness. Though they're obviously the leading video presentation, and IMAX with film, obviously. So did that help you guys in developing such as the Thor, which is one of these big projectors which are DCI compliant and residential compliant, and it's the RGB laser light source. This is sort of the top dog for light output and color resolution. Is that right?
That's accurate indeed. And actually the Thor and the Thor Plus have actually a 6P RGB system. So like you said, 2 banks for red, 2 for green, and 2 for blue, which results indeed in fantastic color reproduction, but also actually provides for a fantastic 3D experience. And I would go so far as to say it's the most mind-blowing 3D image you can get on a projection system anywhere in the world, basically.
I'm glad you brought up 3D actually, because I've even I've been guilty to dismiss 3D somewhat over the years, and I guess it's for a pretty good reason. When you put the 3D glasses on most systems, you kill your color and you kill your light, and that's kind of really you need light to be impressed with a picture to start with, and we're really sensitive to color. So I guess what makes that so impressive is the fact that you've got so much light and so much color. You can sacrifice a bit of that to create the 3D effect, or is there something else different happening with those models to produce 3D?
I would say it's a mix of all those different elements actually, and yes, you could go into all the technical details of why it is that it is resulting in such a good picture, but actually the best recommendation that I could give people is to, if someone happens to be in Belgium, they can come over to our headquarters and we give them a demo inside our headquarters where we have that projector standing there, and then they can witness for themselves. Or they can go online to the Barco website and you can look up where the flagship lasers, so the commercial versions then, are located in a cinema or theater nearby, and actually seek out that experience. I mean, like you say, a picture says more than 1,000 words. Well, in that case, people can experience for themselves. And like you say, we sometimes may dismiss 3D because of the downsides that we associate with it. But when you look at the Thor and the Thor Plus, and like I said, on the commercial side, the flagship laser products, there's none of that. So all of a sudden it becomes like, oh, so this is what 3D can and maybe should look like actually. So yeah.
Wow. Awesome. And actually, yeah, I'll do the same. I'll check out and I'll add some links once we get the video out there to where people can see these big laser flagship projectors in action, because they are, they're in commercial spaces, which the Barco teams obviously are playing in. As I say, the IMAX is one that I know that you guys have sort of partnered with, so I've had a taster of what the big laser stuff is, and we'll definitely find out that link so people can check this out, because that's our reference. You know, we shouldn't be looking at what we had yesterday in our own home cinema, or even what was at the, you know, hi-fi store down the road. It's like, let's see what can really be done. And look, it's a lot of commercial cinemas are working on a budget as well, so we're not necessarily seeing the most dynamic and colorful and amazing projectors in cinema 4 out of 12 at the local cinema space. I'm pretty fussy, you know. I'll go to IMAX and I'll go to the VMAX. I'll go to the biggest and best cinema of a venue, because it is better. It's obviously got the better projectors in there, the better sound. So these are a bit of a pecking order in the commercial game, I guess, as well.
Well, as you said, it's about seeking out and trying to obtain the best possible experience that you can. And then if we're looking at what we're doing in the residential space, it's also about getting that best possible experience that you can, right? And it's funny because a bit earlier, Scott, you mentioned about it's an investment and the return on investment. Actually, we like to think more of it as a return on experience that you're getting when you're investing in these kinds of systems. Because whether you're going for a unit from our high-end series, or you're going for a Prometheus, for example, or a Thor from our Cinema at Home series, in the end, what you're doing there is you're investing in technology to put into a fantastic space. And the main objective is to just, you know, transcend time and space for 2 or 3 hours when watching content or when playing video games with your family or friends or relatives that you got over. So it's all about that. So yes, you're going to be investing in technology and an overall system, but at the end of the day, what you're looking is to get that wow experience, and that's what we enable, and which we find fantastic actually to enable. I mean, if you look at the things that we are able to realize together with our partners, it's just mind-blowing. Simple as that.
Yeah, look, absolutely. And when it comes to time, you know, you never get that back. So, and experiences are the big things these days. And I guess as the world has changed somewhat this year in particular with COVID, I'm sure there's plenty of people now realizing that their home is probably a little bit more boring than they wish it was when you're stuck there longer. And yeah, to actually feel like you're escaping your reality, hence the name of this podcast, drawn into another space, into a story. Yeah, that can all be done with cinema, which is why I love this so much. And to be able to enable that to the highest level, yeah, is quite spectacular. And a lot of people don't realize it's actually available. So it's really cool that we're chatting about what products are really delivering that. And I love that we're talking from the sort of the top, and we'll work our way down into something which is probably a little bit more tangible for other people to pick up as well. Because not only the Thors and these big DCI compliant level projectors hugely powerful for experience, they're a significant process with delivering them. You don't get one home, open the box and stick it on the shelf. Like these things are massive, right? Like, and also there's some rules. They're so bright that you can burn out your eyes with them. So the installation process is very particular, and I believe for you guys even to be DCI compliant, there are a lot of rules involved. You can't just ship it to an ordinary consumer and risk them turning it on and putting 12,000 lumens into the retina. So tell us a little bit more about that process of being DCI compliant and how the installation, the design process for these units really must be ahead to ensure that experience is met on the other side.
Yeah, of course. So there are several things to factor in when we're looking at DCI projection. So first and foremost, as you rightly say, these typically speaking are not small consumer grade products. So to give you an idea, I don't have the exact figures to top of my head, but the Thor and the Thor Plus projector, the main body of the projector is approximately 200 kilos in itself. And then the Thor has a chiller unit and the Thor Plus has two. Wow. I believe they're 50 kilos a piece. So you're talking for a Thor Plus, the best part of 300 kilos of projector. As you rightly say, that's not going to just be put at the back of a room or hung on a ceiling or a shelf. Like a commercial theatre, these need dedicated projection booths where they're isolated away from the main theatre, mainly because of noise. A product like the Thor is going to be generating in the region of, I think it's 78 decibels at its typical temperature. So
it's a true beast. It's a machine.
Indeed.
Yeah.
So you don't want that background noise in the theatre for obvious reasons.
Some AVRs don't have enough grunt to compete with that.
Well, no, correct, exactly.
But in a beautiful high-end cinema, a great cinema is a quiet cinema as well. So that's a really important element.
Yeah, the lower you can get that noise floor, the more efficient your audio can work. It's as simple as that. So removing the projector, actually regardless of the projector, whether it's something like the Thor Plus, all the way down to even our Prague unit, which is quiet. But if you can put that in a separate room or a bulkhead, etc., then it's just going to allow the audio system to work that little bit easier anyway. With the DCI products, we've got power to consider. Often they need a dedicated 3-phase power feed.
Wowzers.
So that's something to consider. They typically have lens shift restrictions, which is part of the DCI specification. So when we're talking lens shift, we're talking the amount of either vertical or horizontal movement the projector is capable of moving off center relative to screen size. So with DCI, typically with 25% vertical shift. Now
so the lens would be a little bit under or 20% under the top of the screen.
Yeah, we basically, if you divide it into quarters, we would be 3/4 up the screen, whereas your typical projection system, integrators would often line it up at 50%, so level with the top of the screen, generally speaking. And then we also have things, as you alluded to, called the hazard zone, which is because of the brightness of the light source and the laser light source, depending on the size of screen you have and the throw ratio, there's a safe distance, or more to the point, a hazard distance the viewer can't walk into effectively. And we have what we call separation heights and widths, whereby you have to be a certain height beneath the light path so that a viewer couldn't look into that light path, or a certain width away from it. So these are all calculations that we would assist the integration partners with, to ensure that the consumer can't accidentally, as you say, damage their eyesight.
Yeah, so the basics of that, if you're all the way down at the screen end of the room, you look up at the projector, you're getting a small portion of that light, whereas obviously if you're within 3 meters of a projector, relative, or let's say the image is only the size of an A4 bit of paper, the amount of power inside that space versus a 6 meter wide screen is
correct. That light intensity is that much more intense that it can damage your eyesight. So that's to manage, to ensure that there aren't going to be, let's say, unfortunate accidents within the residential space, because in the commercial world, often you've got the projector much higher up in the auditorium, that I won't say it's not a problem, but considerably less of a problem.
Yeah, a very high chance in the resi space with a smaller room that this could be an issue, and therefore, care to be taken.
Correct, exactly that. We quite often have to not necessarily redesign, but somebody will send us a design and say, oh, with this work, and we need to often say, oh, we need to just tweak the position of the projector maybe by a foot or so it's slightly higher, just to make sure we meet those parameters. So it's not normally too much additional work, but there is just that additional consideration that people need to factor in.
You wouldn't want to go walking up to the back bar and your team's just kicked a goal and you're going for another martini or beer, and you jump for joy and you get blasted. So these are range. And it's, these are all the little things that people can often not think about prior, but of course, delivering a promise and experience, all these little parameters make a lot of sense. So I was just thinking there was another thing we touched on with DCI content We talked about the resolutions. Actually, what was also interesting is Blu-ray was only around, what was about 30 or 40 megabits a second. And then
Blu-ray, so standard HD Blu-ray is around 40, and then UHD Blu-ray is around 110 for round figures.
yeah, and then the DCI up to 250 or DCP packages about
250 and 500. So a lot of movie content is still 2K in commercial cinemas, and that's where your 250 is. And then if it's 4K, it would be up to 500. And then actually at the other extreme, things like Netflix 4K UHD is around 16 megabits a second. So you can see the gulf of a difference between the bandwidths required.
Absolutely, yeah. And look, it's very clever what Netflix have done and through the Apple TV, to be able to on demand surf through the options, hit play, and it goes. It's like, man, this is better than DVD still, right? I mean, what was DVD running at? Can we think back to?
I don't have the figures for DVD off the top of my head, but yeah, it suddenly
order again or something.
Yeah, exactly. It's going to be not dissimilar to Netflix HD, and yeah, it's although the bandwidths required are much lower for streaming. On the same token, the compression algorithms over time have got so much better that, of course, yes, we're talking, for round figures, I'll call it 15 megabits a second for Netflix. Comparing that to UHD Blu-ray at 110, it doesn't mean that we're going to be 7 times poorer quality, because that isn't the reality, but we are poorer quality.
Yeah, just like the MP3 thing, it's you're picking out the right bits to stay in and which are maybe a little bit more masked, so you let that go. And yeah.
Exactly. As I say, those algorithms have got a heck of a lot better. The gap between the two formats is reduced, but certainly from my perspective, given a choice, if I have the choice of streaming content or watching the physical disc media, or something like a Kaleidescape system as well, where you download the movie in its entirety, bit for bit, and on some cases, sometimes in higher quality than disc, that would always be my preferred choice, because it's going to give you that better experience.
Yeah, I think, I certainly... Look, there's some exclusive shows on Netflix, so that's where you have to consume that content, obviously. And they're very clever like that, controlling their channels, and Apple and Disney, they all worked it out. And though, of course, for blockbuster movies, and it costs, $150 million to create a blockbuster movie. And, well, hopefully it's a blockbuster after they spend all that money, right? So they don't always ROI on it, bro. So much energy and effort's gone into producing and mastering and creating that. And, I'm a big sci-fi fan. Of course, we all love some action. So grab it on at least the Ultra Blu-ray disc. And for a lot of people, that's going to be their best and most accessible way of getting great content, because, we've got a local, big box store that have the CDs and the albums, and they're even selling fridges these days as they do. But, they got 2 for $40 Ultra Blu-rays, and I'm like, this is actually really great value, and it is very high quality, and it's very accessible. I wouldn't believe it's that inconvenient to load a disc. If you're going to sit down for 2 hours after that, there's not a lot of work to do once you load her up. And absolutely, you'll be rewarded for that process over, let's see if Stan have it or Netflix has it. It's so we got a few rules around that. There's no way I'm going to watch a new sci-fi film through anything but Ultra Blu-ray. Though Kaleidescape's a fantastic development as well. They've been around for actually quite a while, but what they've emerged into today is awesome. And I know you guys demo with Kaleidescape probably the most on show, for the very reason that they're a great player. It's stored, so you guys don't scratch your disc. That would be annoying if a scratchy disc on demo. But also, those guys have got their own deals with and I know you can't speak on behalf of Kaleidescape, but I believe they got their own deals with the movie companies. So they got the ability to allow more bandwidth than just the average Ultra Blu-ray disc. Is that true?
Yeah, correct. As I understand it, I think they do some of their own mastering of the content itself, which allows them to play around with compression rates. But the biggest factor there is with a 4K UHD Blu-ray disc, of course, you're restricted to the capacity of the physical media.
Yes.
Whereas obviously with Kaleidescape being a hard drive based system, if they want to exceed that capacity, so Lawrence of Arabia is a good example, with it being such a long movie and such a good transfer from film to digital. I don't know the exact size of the file format on Kaleidescape, but I believe it's something in the region of about 170 gigabytes.
Wow.
So larger, obviously, than the capacity of the discs themselves.
Which is
and that's just because they've been able to play with the compression rate.
Yeah. So Ultra Blu-ray is about a 120 max, I think.
Yes, correct. Yeah, exactly.
Wow.
So
cool.
For the most part, Kaleidescape is bit for bit, so it should match more or less the disc quality. But there are cases where actually they can exceed the quality too, which is really good. It's that kind of compromise between not having either the hardware required for DCPs, the space, so on and so forth, or indeed the budget. You can still go out and buy a movie, and you will pay a premium for Kaleidescape in terms of its content. Not that much, but there is a small premium. But you're getting that slightly better quality content some of the time.
Yeah, so both the content and then, of course, it's a stellar player as well. It's a beautiful playback machine. Yeah.
Yeah, the user interface and the possibility to create your own scripts where you can demo scenes to your friends and relatives, to show off the power and the quality of your overall system is really something, that only they can truly offer.
Yeah, so you've got authorized security, studio, Ultra Blu-ray quality, curated from one scene to the other, and it's all there on hard drive rather than loading different discs and mucking around. So that's really powerful. And yeah, when you do have friends and guests over, you've maybe got half an hour to have a play and to throw some action, drama, music concert, throw all that in there. That's super cool. Because, it's nice to show off a bit.
Yeah, very much so. And as you say, they have the licensing agreements with the studios. So the content you're getting, is all approved content, so on and so forth. You haven't got the headache of, having to figure anything out yourself, which I wouldn't condone. But, you're making sure that the quality of content you get is top notch.
Yeah.
And it's easy.
Yeah, there's a few machines, some French brands that are like the Zapedi that have kind of, worked outside of maybe some of the rules that are in the USA and in their state or country. They're able to store movies, though that storage system also means that it could be a sharing system, which isn't so much copyright sort of playing by the rules. I've played around with them, and they can be a nice player. And it's got that kind of sexy screen, though it is a little bit clunky, and it's like the menu on that thing is just a monster. Even I'm mucking around trying to work this thing out. And for a lot of consumers, particularly those that really appreciate the quality end of the market and they're happy to pay for quality, and in the time that you have, you want to hit that go button and run with it. Last thing we want them to do is sit there loading a disc in their laptop, hoping it will rip to a drive that something might map to and stream. And so, yeah, there's always these little workarounds, but like I would agree, I wouldn't recommend, unless you're one of those tech guys that like playing around, there's something like this Zapedi player, which is really just a convenient or a fancy version of an Ultra Blu-ray player. Though if all of those, your NAS drive and all the IP and the networking stuff isn't going to work for you, that can be more time consuming and annoying than just putting the bloody disc in a nice disc player, I find. So
correct. I completely agree. Stick to the physical media format if you can. It's, as I say, it's not that much of a hardship to go to a shelf and pick a movie that you want to watch and pop it in a player. And if you want to go that little extra mile, look at considering a Kaleidescape system, because you've got that convenience there and you've got the quality.
Yeah, beautiful. And then you sort of almost maybe 5 to 10x a Kaleidescape to start really looking at DCI type stuff, I believe. So it is, yeah. So it is another leap forward. Like in the racing game, it's like that's the F1 really of the game, and it's It's not just a few million more to play that game. It's like 100 million more. So it's like anything in the world when you're pushing those limits, cash is required to fuel that mission. So yeah, it's cool. It makes, and I think in comparison, it actually makes things like the Kaleidescape fantastic value. So again, when you're looking at the top down, you can start to really appreciate some of what these other brands are doing, which very much sits alongside what you guys are doing. So that's really cool. So I think content wise, we've really managed to dive into that really beautifully with that pecking order. DCP, this Kaleidescape, these Ultra Blu-ray disc. Of course, not all players are as good as other players, so I'll leave that for another discussion. It's not a Barco one. Obviously, you guys are like, please just put good content in, and you'll be rewarded.
Exactly. Yeah, it's the old adage of if you put rubbish in, you're gonna ultimately get rubbish out.
Yeah, 100%. So it's actually funny. I had a guy the other day. He's like, "Oh, this picture's a bit blurry," and it's the studio talking to a guy wherever, and the remote image is a bit blurry, but the studio is crystal clear. And he's like, "See how it's a bit blurry?" I'm like, the product's doing its job just fine here. It's the content within the production.
Yeah,
and I was it kind of made me laugh that he couldn't join the dots on that one, but it's it's important. Yeah, quality in, quality out, and it's a great system. It's very transparent. It allows things to be leveraged. But of saying that, something that's okay is going to still be a lot more enjoyable with a powerful unit. That's for sure.
Yeah,
definitely.
Another one I want to touch on is resolution and aspect ratios. And you already mentioned a lot of commercial cinemas are still at a 2K resolution. Does that mean that there's obviously a bundle moving towards 4K, or are they on a different sort of resolution cycle or format to what we experience at home?
So there are two facets to that. One is from a hardware perspective, whereby some theatres purely invest in 2K projectors. And they're often your smaller boutique art houses where perhaps they don't have the space to put the larger machines, etc.
Right.
And then likewise, you've obviously got the theatres that will invest in the larger 4K units. But then you also have the way that the content is produced, which can be a mixture of 2K, 4K, depending on how it's mastered. And Bart, you tend to actually explain this a lot more eloquently and better than I do. So perhaps if I throw this over to you, you perhaps explain this one.
Well, the whole thing about resolution is an interesting one, and it sort of ties back to what we just discussed about the differences between 4K streaming, 4K on a UHD Blu-ray disc or a Kaleidescape, and then 4K in the DCI space. And actually what we have jokingly sometimes say is that basically not all 4K is created equal at the end of the day. And that's because, like you said, because of compression, because the content needs to be heavily compressed in order to be able to do streaming, even though bandwidth has increased and improved tremendously all around the world, generally speaking, there's still going to be compression at the end of the day. And like you said, that one client that you had talking about that blurry image, maybe that was some banding occurrences happening, and that was what you were seeing over there. But then if you would count all the pixels on the screen, yeah, you will find that all 4K or full resolution is there actually. But then if you compare that to the same content, perhaps on the 4K UHD disc, you would notice the difference right away. So are all the pixels there? Sure they are. But the quality of the pixels is a different case entirely. And resolution in itself, yes, it's important for sure. But we think it's just a part of what we call the image quality puzzle, where we see 6 elements that define what a good image will look like. And actually, I should say those are 6 elements that we as a manufacturer of projection systems have under our control, because next to these 6 elements, and I'll dive into them in just a second, there's also other elements to consider where we as a manufacturer do not necessarily control what is happening. So for example, the room itself, which color are the walls, what color is the carpet, which kind of seats were chosen. The screen is another one, can influence the image quality tremendously. Is it acoustically transparent or not? Which gain does it have? Is it microperf? Is it woven? Is it knitted? Etc. etc. So those are the elements even beyond our control. But tying back to the 6 pieces of the puzzle that we control as a manufacturer, I would say you're talking about the imaging device, which in our case is the DLP technology, which happens to be the leading technology in the cinema space worldwide. Next to that, you're talking about brightness, which you need a lot of if you want to do good HDR projection.
Yes. Well, we'll double back on some of these in a minute and pick these apart. So this is really cool. So, yep.
Then you've got color accuracy and your uniformity across the screen. Then number 4 would be frame rate, 24 frames per second versus something like 60 frames per second, as was done on Gemini Man, for example, or Billy Lynn's Long Halftime Walk. I mean, just the impression that you have, I mean, not we, because we know these kind of differences, but if you would show this kind of clip to someone not in the know, they would go, wow, this is fantastic. I mean, is this 8K resolution or whatever? And then the thing is, no, it's still 4K, but it's just a different frame rate, right? And then immediately there's that perceived jump or bump in quality. So
actually, we'll touch on this a bit, because Gemini Man is an absolute stunner. And with the Bauder and the Bragi, which I'm really familiar with, I popped that one on and people they just cannot believe it. It is another whole level. It's exciting because we just haven't ever been used to that sort of experience of the technology. And with this, some people have chose to say that they kind of didn't like it because it was different. And it's like, well, it's different better. And it's, don't be shocked by it, rather than embrace something. And I think what was confronting is when, there was a scene where a grenade was thrown at him and you felt like you're up on the balcony with the guy. So it was more confronting. It was like, you're not used to being in that sort of environment, but the video made you feel like you're in that sort of environment. And I think that's what was maybe confronting, is people were like, well, I'm really in this story now on even an unconscious level. Be courageous enough to get into that story and enjoy it for what it is, or you might have to stick to comedies if that's too scary for you. If you're going to do 60 frames,
True, indeed. Yeah, and then to finish the image quality puzzle, so we've got 4, right? We've got image device, brightness, color accuracy, uniformity, frame rate, and then 5 and 6 would be contrast, and actually ANSI contrast in this case that we're talking about, and how we measure and define our systems. And then last but not least, indeed resolution, because indeed it does play an important part in how the overall image is going to look like, for sure. But just to say that resolution, it's only one piece of what will define or help define the overall image on the screen.
And it's also, we talk about, the pixels on the screen. It's one thing having a high resolution imaging device, so the actual pixel element within the unit, which of course you guys use DLP, and then a lot of Japanese brands that are using their own liquid crystal on silicon, Lycos, JVC, Sony, those guys. And we can talk about some differences with that in a minute, though. So the pixels in the projector, then it's got to get to the screen, and to do that it needs to go through a lens, right? And I guess the optic system is a big part of resolution. That one, when you got the 6 elements of picture quality, and then you can start to break down those elements. So how do you get great resolution? Well, you need a good lens, right? And I particularly point this out with you guys, because Barco has, I think it's like 6 or 7 lens options for the Bragi alone, which is a real standout model. It's also rather affordable, which also makes it exciting to talk about. Though, given a particular throw distance / screen size combination that's required for the install, it's not a one lens suits all and it zooms all the way in and out from here to there. They're very tightly packaged and focus on a certain range, which is awesome. And they're big. They look so cool.
Yeah, indeed. So touching upon that, I mean, yeah, as you say, resolution is one part of the image quality puzzle. And actually, if you go on things like the ISF training courses, which I know you've done yourself, Scott, actually they quite often rank the importance of, you know, contrast and the various different attributes of image.
That's right.
And actually, contrary to what many consumers believe, resolution is actually right at the bottom. It tends to be your flat panel displays that drive, you know, the rush to increase resolution because they need a new excuse to sell flat panels. So pushing that to one side, because that's a rabbit hole.
It's a good, though. Yeah, it's a very good point.
Indeed. What we need to do is ensure that the resolution that the projector is capable of delivering from the chipset is transferred to screen, and that's something called MTF, or modulation transfer function, or modulation of contrast. Okay. We kind of define it just slightly more simply as system resolution, and ultimately exactly that. We're trying to deliver the content from the DLP to screen without loss of resolution, or I should probably more accurately say with minimal loss of resolution, because any system will lose resolution. The pixels will be there, but the definition on them will differ. And we measure that internally with things like line pair patterns or grill patterns, which are sequences of white and black lines sequentially, which gradually get smaller and smaller down to a pixel by pixel level. And that's how we can ensure that we can define the difference between black and white, because the closer those line pairs get together, or those grill patterns get together, if you can't define that, obviously those black-white lines become basically grey. They merge into one another and become a greyish smear. Okay,
so that impacts contrast, which is another piece of the puzzle here.
Exactly. So that's both your contrast and your resolution that's been impacted. And as you say, we have, typically speaking, between 5 to 7 different lenses per product. And the reason for that is we want to produce as high a quality lens as we possibly can do. And it's really, really challenging to create one lens that goes, just as an example, from say 0.8 all the way up to say 4.6 to 1 as a throw ratio. The loss of brightness alone through that lens as you transition through the zoom range, and as a result the f-stops, is quite immense. So we focus on producing extremely high quality lenses with a much smaller window of throw ratio, so that quality of lens is optimized to deliver that true resolution capabilities of the projector and maintain the brightness, the white field uniformity, and all of the other attributes of the image quality.
Yeah, awesome. Because you imagine if you're long throw, you're closing down the lens, trying to make the image smaller, which is the exact opposite to, you know, the very basics of fundamentals of photography. Is you open up the aperture to let more light in.
Exactly.
Same getting it out the other side with projection.
Yeah, and as an analogy for customers to understand, it's always actually really good to relate back to photography, because a projection system is effectively doing the opposite to what the camera lens is doing. And people can tend to then picture that a little bit clearer in their head in terms of the mechanics of what's happening.
Yeah, no, it makes a lot of sense. I think even with, you know, our more general all-in-one products like a Sony, which is, you know, it's one lens option from the factory. These guys playing typically a little bit more entry-level price point to you guys, so they don't quite have the same luxuries. Though, you know, if we're shorter throw and a more open lens, it can be a good 10+% difference in just the how much the lens opens up.
Oh, even more than that in some cases. It can be up to 25% in some cases. Wow. The swing in terms of brightness loss. And then there are other contributing factors as well in terms of just sheer, you know, lens quality. You know, you've got the difference of plastic versus glass optics, for examples. You've got the different coating types within the actual individual lenses that make up the overall lens. We can have up to 20 different coating layers on the glass itself to make sure that the colors aren't separating within, that the optics aren't getting damaged because of the light that's going through them, etc., etc. And it's all of those very minute details that go together to ensure that ultimately our system resolution is extremely high, so that if you count the pixels, they're all there, but also if you then look at the quality, as Bart says, of those individual pixels, that's high, and there's no interplay but from one pixel to another, for example.
Right, which could be blurred between pixel to pixel from, I guess, electronically controlling them in a processor, which we haven't got to yet. And then, of course, optically on the way out, these pixels sitting right next to each other can get blurred. So
exactly. And likewise, you then have things like chromatic aberration and all of those sort of things, which is where the light is separating into its individual components.
I think Dark Side of the Moon, that gives people a flashback to year 9 science at school, the prism breaking the light source into multiples, and that's exactly what happens to a degree through any lens system. Hence how we get beautiful rainbows. This is a element which needs to be tackled. So I just sort of give those reminders of people. It's like, oh yeah, that's what happens.
And on some projectors, you physically have to go into a menu and then realign the colors, which on a Barco, certainly on our single chip projectors, not an issue at all. So yeah, it's all important things that then help us provide the best quality image that we can.
And I guess with that, because I saw a lot of those problems when working with Cinema's anamorphic lenses, and it was great when we first started getting into anamorphic lenses. That was probably 13 years ago that I got introduced and started working with that. And we're like, wow, this is awesome, right? Big wide screen, and it did help get more light on the screen, though. We've got a lens into another lens. And, we had some pin cushioning of the picture, and we had some, even just the basic test pattern of the projector was, blending out. And there was a lot of problems with particularly some of the cheaper brands that were shocking. So as you add more elements, you're adding more, as you say, any system is only going to have a certain amount, have loss. So each time you add something in, it's like, well, how much loss can you minimize and never delete? And that's where it's really cool to chat about now, I think, the Cinemascope chipset. So for people that can and want to go to the beautiful immersive Cinemascope format, you don't need another lens, which can just cost us more resolution and contrast performance. Instead, you can use the same high quality lens that the chipset natively is projecting through, which is your CS range of products.
Yeah, indeed. And actually, besides like you just mentioned, Scott, the cost of image quality that you're gonna get, meaning the image quality is gonna go down. There's also, of course, the additional cost of the lens itself. I'm not sure how much it would be in Australian dollars, but over here, sorry about that. That was the bell ringing.
That's a good idea.
Yeah. But over here, the good quality anamorphic lens will set you back anywhere between 10 or 15,000 euros extra. So that comes on top of your projector that you're already purchasing, right? So that's also another factor to take into account, I would say. But yeah, indeed, come back to our Cinemascope models. Like you said, they're outputting in 2.37 to 1 aspect ratio at a 5K UHD resolution, actually, and providing convenience. Again, when we were talking earlier about that convenience of streaming, that convenience of using a Kaleidescape system, for example, it's the same over here, right? You want to have a fluent user experience. You don't want to be messing around with different settings, trying to find out what is what on the remote. You just want to have it as automatic as possible. And that's what we enable, because on our systems, we detect the incoming signal. We detect whether it's 16:9 or Cinemascope content, for example. And then we adjust the image on the screen accordingly. And that just happens like flick of a switch, basically.
Works great. With the Projector, which is the control system via IP, so the laptop has the full dashboard of what the projector is up to, and I can see that as different content changes and we're switching, it's like, oh, this is 1.78, this is 2.2, and yeah, and of course the result on the screen follows, which for end users all that matters. Though it's been even putting different ultra Blu-ray discs in, because I've got some nice video generators for calibration, but I don't have the other side, which is the sort of the receiver end of the data system. So I use the barcode Projector to give me the data, and because the barcode reads it all, and it's like, well, this is this many nits, and it's this aspect, and it's this color, and allowed me to do some research on some of the discs that we're playing on. And yeah, aspect ratios, one element of that. Even more so, you've got the really powerful warp engine inside the CS projectors, the Bragi and Bowder and the Loki models, which are all using the Cinemascope chipset. The warp engine, which I believe is what's really more so used in the presentation, or what do you call it, the projecting onto buildings game, digital signage. I think I've got that right eventually. Yeah, which you don't really need in if we've installed the projector right and the screens right, we don't really need to muck around with that. But for, some people love their football bigger and wider, and I'm yet to do this, so I got to go back and play with this, but it's like, oh, maybe we could crop a little bit, but make sure the score's in there, and I could stretch that out a little bit, and I can kind of pull the football out into the scope space a little bit and give them a bigger screen, and it can do that without terrorizing the picture, because as we run anamorphic systems, or we do any level of maybe blending and cropping, the video processor has to number crunch. 4K to 4K is easy, it's 1:1, right? But anything in the middle, like, hey, getting rid of these black bars, we now need to present that picture over a wider range of pixels than originally the source was potentially intending. That algorithm of making sure everything fits and works and flows. I know in the early days when we did anamorphic, and how did we do it? We had to expand the picture.
Yeah, so typically the image would get stretched so that the black bars were effectively lost within the DMD chipset, and then the anamorphic lens would stretch the image optically, horizontal plane. There is another way of doing it, but that was the most common way to do it, typically.
Yeah, and how we processed that would make or break the picture, because there was a mode in one of the projectors which had an anamorphic mode, but the picture looked shit. I was like, oh, what happened? And then we used a little DVDO machine. Those guys aren't really doing video processors like they used to. And we put a stretch on the DVDO box, and it pretty well maintained the nice picture we had. But now we got rid of the black bars and we had the big screen. So that showed us very early on that you can't just stretch and warp and do whatever you want with a picture, because it can really stuff it up in the process. So you guys need to particularly process to get Cinemascope happening. Can you tell me a little bit about how you guys do process picture? I've just seen the results, bad versus good. But can you tell us a little bit about that?
Yeah, of course. So if it's cool, I'm going to backpedal ever so slightly. So cool. The warp engine that we deploy isn't actually exclusive for the Cinemascope product. So it's relevant for both our 16:9 and Cinemascope products. So anything from the Medea up to, in the present range, the Loki and Loki Cinemascope products. It's not available in the DCI product because Hollywood don't want us, obviously, to manipulate content.
Their intent. You gotta leave it alone.
Indeed. In terms of its heritage, you're right. We both use it in Pro AV in terms of projection mapping onto buildings, for example, but actually more commonly we use it within the simulation, and that can be simulation of aviation simulators. It could be Formula One simulator, ships, cranes, all of that sort of thing, where we quite often have to project maybe 3 927 projectors onto a very large screen that can be curved in multiple axes, blend those images together. But of course, where we're talking, as I say, perhaps aviation or even military, mission critical simulations, the image quality has to be effectively, equal to what went in originally. So the output has to more or less match the input, which means we need to process the image in such a way that there's almost no perceivable image artifacting, which is obviously common when you start to scale the image, but also no latency or no perceived latency, I should say.
Fast as well.
Which of course means that as you put an input into, let's say it's an aviation simulator, as you turn the joystick, that on screen has to react as though it would in real life.
Wow.
So that's key for us.
Yeah.
So within Warp Engine, Barco's pioneered something called single step processing. And there are typically 3 steps to warp. The first is scaling content as required. So obviously in the residential space, everyone talks 4K, but actually half the time we don't watch 4K content. We're watching content from, in the UK it's Sky. I don't know what broadcasters you have in Australia, but your broadcast, which is perhaps 1080p, transitioning to 4K. You might have old Blu-ray players, etc., etc. So we've got to scale all of that content to 4K. We then need to manipulate the image if we're going to. So we need to understand if we've had to warp the image, where those pixels now reside on screen. And then we need to prepare them for the imaging device to actually output. Now, a lot of companies do all of those processes on different chipsets within the projector on different boards. So they have to transfer data from one chip to the other, from one board to another, which inevitably adds image artifacting or latency to the image. So what we do, the easiest analogy for end users is, I say, it's visually, it's very, very similar to Keystone in as much as we're correcting the geometry of the image.
Yes.
But from a technical standpoint, is apart from Keystone correction.
Because Keystone is a little bit of a dirty word in projection, because
indeed,
really mucked it up.
Very much so. As soon as you add Keystone to a projected image, if you look at text on a Kaleidescape synopsis, or if I was to pull up my my TV guide, for example, the first thing you notice is that text instantly, goes to pop. With our technology, that isn't the case, nor moving images, etc., etc. So that's kind of the background of warp, and we use it, as you rightly say, we use it in 2 ways. We do use it with our Cinemascope projectors to stretch content to be able to watch, the soccer game in full widescreen, which I'll come back to in a moment. But the other way we also
some numbers I can type in, so I don't have to work it all out.
No, indeed. But the other way we use it is actually, if we look at the installation behind both Bart and I, we can see that the projected image is actually coming from the far right-hand rear corner of the room. So not at the center of the room as you typically expect, because there's a lampshade in the center of the room. So that allows us to do some quite unique and extreme installations, yet correct the geometry and the image quality on screen so that it's as good as it possibly can. So that in itself is probably a completely another conversation, but I just thought I'd touch on that. But you're right in saying we can take that same technology and we can switch between our 16:9 content and our Cinemascope content and every aspect in between. That's using that technology, albeit we wrap that up into a feature called cropping as opposed to warp. But then we can also use that same scaling technology, as you say, to take 16:9 content or 185 content and do either a linear stretch or a non-linear stretch of content. And the difference between the two being a linear stretch is we literally grab the sides of the content and stretch it left to right evenly. Of course, then if we had circles on screen, they would become oval shaped. or we can do a non-linear stretch, which still grabs the corners and stretches them across, but the stretch is applied unevenly or in a non-linear way across the screen. So the center proportion remains largely undistorted, and the peripherals become more distorted. So depending on the content you're watching and viewer preference, you can choose to do either or.
Yeah, which is cool because, as you say, the peripheral, we're less resolution in our eyes there, and we're also less aware of what's happening there. So if that could but if we can still get some light and environmental sort of information of the show out that big and wide, that can be really entertaining, even if it wasn't originally created that way.
Indeed.
But what you will notice is if the round soccer ball's now oval in the middle, that's then unconsciously saying something's wrong here, and that really kind of ruins things. So yeah, that kind of nice balance there with the non-linear stretch of trying to have our cake and eat it too, until the soccer or the F1 is literally filmed in Cinemascope. That would be nice, but until then we get that nice balance. So that's really amazing. So you've got obviously huge investment of technology gone into the mission critical applications, simulation, and then you guys can sort of go, we'll have that, thanks for working on that, and we'll bring it over here to the residential projectors. I guess it's oversimplifying it, but it's nice. I think Audi, they own so many garages, car manufacturers, they can kind of go, yeah, we might just get that V12 over there and we might put that into this one, and they can build some pretty cool stuff from some phenomenal R&D, which makes them a powerhouse. And
indeed, it's a good analogy. We have the benefit within the residential segment to be able to, because of what the wider organization is doing with its work in simulation, pro AV, commercial theater, and even in the medical environment, we can look at other technologies from within and as you say, kind of go, that bit over there looks interesting. Let's see if we can develop that for the residential market.
That's awesome. That's really powerful. So to say every time you add an element into the path, you can only really stuff it up. Of course, the goal is to add a valuable improvement. Though, yeah, I mean that's another component you guys have just absolutely ticked off with the processing side, and that's totally evident when, of course, we get to watch them. So the chipsets themselves, we're sort of working all around the place here, but this is good fun, and I think people are following along all right. So DLP chips in $1,500 projectors, and then these DLP chips are in $500,000 projectors. Obviously, there's more to it than, every car has a wheel, right? It has a steering wheel, so we get that. Barco do use typically bigger chips and select chips which are of higher grade, and there's a few things around them which doesn't make them all the same. So what can you tell us a little bit about the chipsets that you guys do use? And then I'd love to hear about how the hell you make a Cinemascope chip as well. That's kind of cool.
Well, first of all, like you say, let me use a similar analogy as I did when we were talking about resolution, right? When we said not all 4K resolution is created equal. Well, I guess you could say the same thing or similar thing for the chipsets, because like you say, other manufacturers in a 1,500 or 2,000 euro or US dollar projector is not going to be the same thing as what we are employing. So there's different levels of different grades of quality, let's say, and indeed we are using the higher quality grades. We're also using the bigger chipsets, as you correctly mentioned. So that sets us apart from other manufacturers in this space. It also means that this is why we were able to do what we do, right? Provide systems or projection systems that have extreme color accuracy, have great brightness, which you need if you're projecting on 3, 4, 5, 6, 7, or even up meter wide screens, which is what we're doing, right? Because there's tons of other manufacturers who are active in a space for screen sizes anywhere, let's say around 2 meters or 2.5 meters, and they're doing a great job at that. But
about 100-inch sort of screen size. Yeah.
Exactly. Yeah. Thank you indeed for that analogy. That would be that region, and that again, that's perfectly fine. But we are not active in that space. Why would be? I mean, like I said, other manufacturers are doing a good job at that already. What we are trying to cater to is the market of, let's say, 3 meter wide and up. And again, if you want to have a great, punchy, impactful image on the screen, this is where you're going to need quality components, be it the chipset, be it the quality of your lenses, basically the overall system, like Andy mentioned or explained earlier when we were talking about the system resolution projector really.
Cool. So a bigger chip, you can obviously bounce more light off it. Is probably the one big advantage to a bigger chip.
Yeah, so you've got the ability to bounce more light off it. You've also got the heat that you need to consider. So the dissipation of heat within the chassis itself, and how you can, obviously, the more lumens that you're projecting onto the chipset, we need to manage that within the projector. So of course, a bigger chipset in itself allows us to do that.
Yeah. Wow. Yeah, it's a good point. You got like 6,000 plus lumens of laser power bouncing off this little thing. I guess it means with a bigger chip, it means you kind of need bigger lenses as well, because you've got a larger image to start with.
Exactly that. So the lens itself will have a larger image circle, which, of course, means that the cost of the optics likewise starts to increase too. So, there are lots of knock-on effects of obviously having the bigger chip.
No free ride. Yeah.
Indeed. Of course, then the chassis of the projector becomes slightly larger too, and that's twofold. Partly because things, as you say, like the optics increase in size, but also, to generate the extra light, we need bigger components, more laser arrays or otherwise. But of course, you then need all of the cooling attributes that go with that to dissipate that heat. So that's all the factors that don't necessarily evolve around the chipset, but all that come together, that our expert engineers across our multiple facilities need to work together to figure out to provide the optimum product size versus light output versus noise, etc.
Cool. And DLP, as we sort of most people would know, listen to this sort of show, is the choice of commercial projection, and the reliability has been amazing. In fact, I think I've never had in my time a DLP chipset let go. I've had color wheels, and I've had lamps, and I've had all sorts of other things in various brands. Though DLP chips have been really, really strong. So, the longevity and reliability is there. And I know for you guys in the simulation world in particular, they're expensive to run. So they pretty much book out those things like 24/7, like they're always running, because, they don't have hundreds of these things around the world. They get people in to train and book that thing out. So, reliability, and you say with a lot of heat, that's going to be the Achilles heel of most systems if they're going to run for that long.
Yeah.
So the same quality in those spaces are effectively in the residential range as well, because the residential products have got the big chipsets also. So
correct.
There's no cheap version of the Barco.
No, we don't compromise on the chipsets in the residential space. So we benefit from exactly that same chipset. Well, not necessarily exactly the same, because we'll modify it or make sure it's appropriate for residential space. But that same grade of chipset we would benefit from.
Awesome. And the Cinemascope chip. So Texas Instruments, because they're the suppliers, the manufacturers of this technology. I believe they're in the US still, in Texas maybe. Wild guess again. So they don't maybe build a Cinemascope chip as such. This is something that you guys have either requested or you guys modify in the factory. Or can you give away a little bit on how that happens, or is that secret stuff?
I'll take that one, Andy. I'll take that one. I would say that's definitely part of the secret sauce that makes Barco Residential and our Cinemascope models exactly what they are, right? So unfortunately, as much as maybe we like to go into that, no, that's something that we're not going to dive into, unfortunately.
Okay, cool. Well, it is absolutely unique, and the vast majority, in fact, all of the Barcos we've done recently are all in Cinemascope. It's evident just how amazing that experience is. In my little demo room here, we sort of got a 16:9 screen because I thought as wide as I could go, but then I'm like, hang on, I could get a slim border and I could maneuver a few things. I still, in the given room, right, things have to fit in your room, and I'd still need to open the door, which is kind of at the frontish of the room. So that is ultimately where I'm going to tap out. Though what I've found interesting, and I guess adding some context to why you guys, why Barco build this stuff, is the viewing angles that we like to see, and hence why movies are created. Almost 80% of them in Cinemascope is to immerse us because our vision is wider than it is in height. And I know where, a 45-degree viewing angle is considered sort of the reference-ish point of video and beyond. And it's a personal taste. I mean, not everyone dives to the front seats of a commercial cinema premiere. There's plenty that will hover around the middle, and some people would even stick more towards the back of a room. And this is the really cool thing with home cinemas, is you can build the cinema to suit your exact preference, which is why I chat to clients a lot about, well, where do you like to sit? Though the reality is a lot of rooms we're in, we're not always in massive spaces, and we're limited with how far back we can get the projector to get a big enough picture, which can be a struggle with a lot of the brands I deal with. I'm maybe just touching on 45-degree view, given the main seats. And I wish I had extra. And that's really cool because you guys, with the lens options, it's like, no problems. Let's just put a wider throw lens in. And if we're only firing from 4.5 meters away and the seats are going to be, say, 3.5-ish meters from the screen, we're looking for almost a 3.5 meter wide scope image. Almost the viewing distance is almost the width of screen and we're chasing. We can do that with the lens options without compromise, which is really cool. And as I say, a 3.5 meter seating distance is often a 3 to 3.5 meter wide screen, which puts a lot of brands sort of, for a given install, they're out of the game straight away. The scope chipset and the big lenses means, we don't have to compromise the installation, which is really cool, because there's nothing more frustrating than looking at, our target calculators for this room, and it's like, well, we can't get there. And can't's a silly word. It's like, how can we get there?
Exactly. And technology being as powerful as it is nowadays, if you use it in the right manner and treat it respectfully, it allows you to, combine all these different elements that we need when we're creating a high-end residential experience for our clients, be it a dedicated home theater or be it a more media room application. And then indeed, like you say, it would be a shame or a pity if you let the physical circumstances of the room dictate the limits of what that experience can be.
Yeah.
And again, cycling back to what I just mentioned, there's so many options that we have in our toolbox, basically different lenses with the different throw ratios. There's the power of the warp engine that we've got on board, etc., etc. Using all those elements combined, there's little rooms that we cannot incorporate one of our projection systems in, Again, that provides different opportunities, opens up people's minds to what can be done, to what is able. And all of a sudden, it's like, oh, I wish I had the ability to do a 4-meter wide screen in this given room. Well, guess what? You can. Let's sit down together for a second. We'll show you how we do it, because we've got these different lens options. We've got warp, etc., etc. So
yeah, which is awesome. We can design a room based on the experience outcome, and then package up the solutions to get the job done. And there's a lot of limitations in some areas where we just can't do that. But the Barco Residential are opening that wide open. And there's a number of solutions you guys deal with, which I haven't personally experienced, which in the way of, the projectors mounting vertically, and then, which I believe is the installation image behind you guys now. It's a vertical installation. It mirrors off, it angles, it warp engines, it all comes together. There's a whole world of media room and outdoor entertainment, which you guys can just go absolutely grandioso on with picture quality, which, if folks invite their friends around for the big game and they've got a 200 or so inch screen, the 85-inch TV starts looking pretty lame all of a sudden, that's for sure.
Very much so. I mean, we can do installations more or less in any environment, and we could very easily pull together a partner and some of our other colleagues and actually realistically very easily do another similar session, an hour long, talking purely about that, the non-dedicated space, because there are lots of things that we can do in terms of hiding a projector sympathetically within the architecture of a room, so that all you see ultimately is the image. You don't see technology getting in the way of that, which is typically both customers and designers' issues with projection systems. Is the technology tends to get in the way.
Right, a bit more rigid in what it needs of the room rather than what the
Correct.
design of the room's looking for.
Exactly. So we've partnered with a few people that allow us to really install a projector into almost any situation.
Awesome. Because obviously we're very much living in the custom cinema space, where I am or focused on, and we've got a fair bit of lenience. We can put a hush box in. We might have the room behind the projector room can be on a new design, could be really cool. And given that we're kind of in a black immersive interesting room, or a bulkhead, we can kind of get the job done. But an open plan or an alfresco or something like that, there's been a lot of design planning already in place. So that's really cool, and that might be something else that we could check into for another podcast, because I know these folks out there that love their cinematic and their hi-fi experiences, and they're really starting to bring that into other spaces around the home as well, which and hence the move with architectural audio being so powerful as well, which is really cool. And I'm reminding myself on my little speaker box that I listen to a lot in the kitchen, and how underwhelming that is, and how I'd really love some big audio on there. But at this stage, it's all in my cinema room, but I shouldn't complain. I'm still doing all right. So I think we've done great on sort of the aspects around resolution. What I move towards now is color, which is another really big part for following a little bit more of an ISF and end result, sort of how do we appreciate picture, which is light and color, and how natural that color is in particular. So I'll talk about color now, but how that fits into the 6 components for you guys, and what technologies, I guess, are embraced today to deliver a beautiful natural color. And of course, with Ultra HD Blu-ray, we've moved from a small color palette of Rec 709, the technical term, to the P3 color space, which is what I believe the DEC or the commercial cinema space settled on as a quality color reference. When they moved from film, they're like, we need to reproduce a good range of color here, and that's something which I think was quite noticeable in the commercial cinemas that they had over and above home. Was the color space. There was, looking at a high quality Blu-ray picture at home, there was something missing, and when you go to the commercial cinema, it just looked more beautiful, and I think color was a really big aspect of that, and we're sort of bridging that gap. So I'll let either or both of you guys touch on. I mean, colors is kind of a big segment here, so I'll let you guys comment, and we'll go and flow along the way.
No worries. I don't know, Bart, whether you want to go on that first, and then I can add to that if needs be.
Yeah, gladly. I mean, indeed, there's all these it all cycles back to that image quality puzzle, right? I mean, it's becoming more and more clear, right? We talked about resolution, we talked about contrast of the system, we talked about frame rate already, and indeed color and color accuracy is another big one. I mean, if you just look at the way that content is captured, so talking about the camera systems, the work of the director of photography there, but then also in the workflow afterwards, I mean, digital effects or visual effects being added, color timing being applied to the image, different mastering paths for SDR versus an HDR version of that content. It's I wouldn't say it's opening a can of worms, that may be too strongly, but still there's all these different elements to consider. And I mean, if we're looking at home video, there have been a couple of releases over the years where well-known films or well-known, let's say, properties were re-released for a anniversary edition, and all of a sudden you had this reaction in the audio video file community of, oh, this doesn't look or sound like what I remembered it being. And then it became a question of, yeah, was the original director involved? Was it approved? Was it the director of photography? Was it the colorist, maybe, etc.? So there's all these kinds of elements to consider when you're talking about color and color accuracy. So that's again one element that's entirely in the content generation side of things, which we as the manufacturer do not have under our control, obviously. What we do try to do, and that's linked back to our commercial cinema heritage that we have and the activities that we have there in partnerships with studios, is to recreate that director's intent, which is being talked about more and more. Similar to frame rate, actually, I think it was last year or maybe the year before, where we actually had the likes of Christopher McQuarrie and Tom Cruise doing that public service announcement type video in the US, when they were saying, look, dear folks, we know that on your television systems, there's these things called motion interpolation and whatnot, and every manufacturer seems to have a different name for it. But actually, we as the filmmakers, we would prefer that you turn off this feature because we feel it is not cinematic. And it goes back to that whole thing, right? So it's about the director's intent and making sure that you reproduce, or that we reproduce as faithfully as possible what was initially created in there. And an important part of doing that or trying to achieve that is making sure that our systems are properly calibrated. It would seem that everyone in our industry would calibrate their audio systems, and rightfully so. But unfortunately, we still see a bit too many projects where the video goes, well, here's the flat panel TV, or here's the projection, we'll do some basic setting adjustment, and voila, there's your image, there's a picture. And there's a little bit more to it than that, right? So why not go the extra mile and make sure that your video image is calibrated as well?
Yeah, and particularly when these number of elements, as you say, you can't control as a manufacturer, which is the room conditions and the screen, and by the time that projected image ends up reflecting back to the viewer on the other side of the room with all these other elements considered, that's going to change the perceived picture, or even with test instruments, the actual measured accuracy of the range as well. So yeah, that's always a big one, is verifying what we're getting, and verification is always right at the start and throughout the process of calibration. It's like, are we getting what it said on the box? Are we delivering what was promised? So do you guys have your projectors, I guess, calibrated to a certain reference as it leaves the factory? Is that at least a starting point for you guys, even though I know that you don't know what the screen will be or what the room will be like? Or I guess there must be some testing process involved, or you guys just sort of reference color off the neutral reference screen, which is that 1-to-1 gain, super dispersed. What's your sort of process for getting some sort of standard there before expecting the calibrator to finish it off?
That's an interesting one. Let me put it this way. Just recently, we went to calibrate a Loki Cinemascope at a partner of ours. And when we arrived first, they were like, well, actually, we think the image looks fantastic as it is already. And we were like, well, thank you. That's great to hear. And we're grateful that you're already glad with what you're seeing, with what you're experiencing. But, let's go through the process. Let's go through the different steps. And then, at the end, tell us your opinion. And they were there for the whole calibration process. And then at the end, their first reaction when we finished the entire process was just, wow, This is amazing. I mean, I'm not kidding you, Scott. This is exactly their reaction that they had because they were already so impressed with how everything looked in terms of color and saturation and punch in the image and whatnot. And that is a testament to the overall quality of our projection systems. But then, like I said, you want to eke out that remaining X amount of percentage, whatever it is, and that's going to be depending on the screen, the room, etc. You want to get it out there and really perform at the best level that you can with your combined system. And that's what we're getting when we're doing the calibration.
Yeah, given that there's sophisticated instruments and we're harnessing power and all these elements, it's a bit like a race car. I always come to a race car analogy, and I think a lot of people kind of follow that easily because we're all, we drive cars. We kind of get some basics around it. Though, if a general person were to hop in a race car and go around the track, they go, "That's friggin' amazing, right?" But you get a driver take it for a lap and you go, no, it's not quite right. We're gonna tweak some things here, and then you go, give it a run now. It's like, oh my lord, it's another whole place.
All of a sudden, you got the down tune, the downforce adjusted. You got the spoiler, you got tire pressure, etc., etc. It's all of those little elements, indeed. Yeah.
These more.
And you can take that analogy slightly further as well, in as much as obviously every individual's room is different. The color of the walls is different, and that's going to have an impact on the calibration. And going back to the driving analogy, every track is different. So that's obviously where we need to calibrate for the room to ensure that we're color accurate for that. And likewise for the content that we're watching too. So obviously, I think we've said it a couple of times, with our SDR content or our standard dynamic range content, that should be mastered at Rec 2020. And with our HDR content, that's mastered DCI-P3. So we need separate calibration profiles to enable us to...
2020 or Rec 709, sorry, for SDR.
Yeah, SDR Rec 709.
SDR is 709. HDR is DCI-P3. But it's delivered within a Rec 2020 container. And Rec 2020, P3, and 709 are what we call color gamuts. I don't know whether your editing team can do this, Scott. I'm sure they can, but the probably easiest is if you pop up a CIE chart and you can see the triangles that the colors will fall within, with the red, green, and blue being the extremes. And as we transition from Rec 709 to P3, you'll see that color gamut widens. So the blue remains largely the same, but our red and green are extended. So we can make our skin tones look that little bit more natural, or the green of trees and what have you look that little bit more natural. And also the color volume increases too. So the amount of light intensity we can put into each of those colors. And that's all part of HDR. But of course, it means that we need to, in an ideal world, do a calibration for HDR and a calibration for SDR.
Yes. Just as we started nailing SDR, the goalposts changed.
Very much.
It used to be hard to get a HD cal to really stick and get grayscale good. It wasn't always easy. And then we're like, nail that. And now HDR is tricky. So it's worth it. It's a cool technology, but it's tricky. It's a tricky game.
Yeah, for sure. And we within Barco, we've employed tools that can either be used or not used, but that can make the process that much more easier. So first and foremost, within the projector itself, we have what we call real color, which is our calibration process. That means we can, albeit with the appropriate hardware, calibrate the image using just the projector and a color probe. But then we have other facets within that allow us to detect the incoming video signal, actually switch between Rec 709 and HDR calibration profiles with our own algorithms. So which means a calibrator, if they choose, can just do a single calibration to HDR, and then we rely on our algorithms to switch between SDR and SDR. Or if you want to eke out that extra performance, then you can do your own individual calibration profiles for SDR and HDR.
Which allows you to verify 100% rather than an algorithm going, should be this, you can really dial it.
Correct, exactly. And that also is really important for things like, CDR projects, entries, for example, where you need to be able to provide that paperwork to say, this is my Rec 709, this is my HDR. Oh. And then also you've got the nuances of HDR as well, with the different mastering luminance levels that in themselves ideally need separate calibration profiles, but we also can analyze that incoming video signal, detect the mastering luminance, and actually set up the screen luminance correct. So you've kind of got the ability of you've got the non-calibration method, which is Bart says, our projectors look fantastic because the engineers at the factory put a lot of effort into making them, but you're not then tuning it for the racetrack.
Yeah.
You've then got the ability to do that first step, which is very, very good calibration, which is kind of curated by us, for want of a better word, where we detect the video signal and just put it into the right mode. And then we cater for the professional calibrator that really wants to go into those finite details and do 2 or 3 different calibration profiles for different content types. So we allow the ability for everybody to do what they choose.
Yeah, it's really powerful. And when particularly, or I'll make a comment here as well, is with particularly color, so richness and fullness and saturation and how natural that color is definitely in the calibration process. Though also these are trade-off when we're looking at the overall game of putting together the ideal pictures. If we want more saturated color and we want to gun for P3 color, which is a deeper, richer color space, we often chew up light output.
Yes.
So as we go for deeper and more saturated color, it's a bit like having, I guess if people could picture light going through clear glass, you get a lot of the light out the other side. If it was a red piece of glass, there's left light out the other side, and if there was a dark red piece of glass, there'll be even less out the other side. But of course, the light on the other side keeps becoming richer and deeper with color. So these projectors out there saying, yeah, we do P3 color, and when that P3 color space is attempted, because I still haven't seen them really nail it, then the color output gets chopped by about, we got like 30-40% of the actual intensity of the light left over. What's interesting with the Bragi and which these are the Cinemascope models we talk about a lot, we got like 2,000 plus lumens, and we're getting very close or full P3 color with that. So these, or in the likes of the color wheel models, if you back off the color saturation for say more of a sports media room, and we just want share light output, we can get like 6,500 lumens off a Bowder, something like that. Feel free to correct me if I'm wrong with some of these.
No, I think we're spot on there.
Spot on. And though if we go, okay, we want max for cinema in a dark cinema environment, we want maximal color here, then we'll crank up that color wheel. It's actually a different color wheel. I know we've done some swap outs where actually our first Bowder only had the theater model running at the time, theater and media model, and then the P3 color wheel came out shortly afterwards, so we had the pleasure of opening it up and loading that in. And actually I've got the old color wheel here. I kept that as a souvenir. It's a cool looking device. So we lost so-called light output, so measured lumens. I think we're down to about 3,500 lumens in P3 color on the Bowder.
Yeah, just over.
Yep. Oh yeah, about 36, 37. So yeah, these that sort of trade-off there, though. I guess we touched on HDR level light output. So there's no real particular standard when it comes to HDR. Almost anywhere, it turns out, the way it's been implemented with metadata and studios, it's a bit of a moving target. Though in projection, there's no reference in is it SMPTE Society?
Yeah, correct.
Yeah. They haven't said this is what you need. So it's taken likes of you guys or maybe the Dolby Vision cinemas. I think they run at around 35-foot Lamberts at a Dolby Vision cinema. Though you guys have found that, Barco have found if you can get about 40-foot Lamberts of light output on the screen. Now, for those that aren't quite following, foot Lamberts is the typical measurement of light output coming off the screen back to the listener. Viewer, in the audience. And I don't go out of my way to convert that to nits, but it's nowhere near the 1,000 nit references of TVs. It's maybe more like 100. The 40-foot sort of is where you guys are like, wow, this is where this HDR technology in a projection application is really starting to show something special. That means on a 3-meter wide screen, on a typical, say, I'll mention some of the other brands like the Sonys, and they're 1800 lumens, for example. We're getting maybe 20-foot Lamberts on a 2.5 meter wide screen. So here we are stretching into 3-4 meter wide scope screens, and a typical viewing distance in a cinema to hit that immersive, 45 to 50 degree viewing angle, and our light drops off. But then we want great color, and our light drops off. So, this is where something like the Bowder model, which starts at 6,500 lumens, and by the time you P3 it up and blast it onto a 3.5-4 meter wide screen, we've still actually got around that 35-40 foot reference light output for HDR, which is truly spectacular. So that's some of the challenges or things that I've found in designing systems of balancing color whilst chasing the HDR dream in projection, which I know for many folks it's a dream because they have not yet got a hugely powerful projector, and I do wonder if some of the other technologies are not so capable of the light output because of heat. Like you guys were saying, we could speculate that the smaller Lycos chips might not really handle 3,000 or 4,000 lumens of laser power over a period of time. So I'm sort of like, even like, I could handle a lamp projector if it gave me the light output and the color. I'd sacrifice that. Though, obviously you guys are quite cutting edge, and you're like, look, we got the light, we got the color, we got the new technology. It costs what it costs. So lamps are seemingly sort of going down the wayside for you guys. So what's sort of the future for you guys, do you think, around light engines and color space, and obviously we want lots of power? How's all that sort of looking? Obviously we can talk about the current ranges, which are already delivering in those areas anyway.
I would say we're constantly looking at different technologies and how they evolve, both from a performance point of view, but then also a quality point of view, i.e. how do they perform over time? Because we want that experience, you want that image that you're seeing at the start when you just unbox the projector. Want that
so
to be
I guess
the same.
that's probably why lamps are undesirable for that very fact. Yeah, makes sense.
And also from that user experience point of view, when you're watching your image, let's say 100 hours in, it's going to look great. But when you're nearing the end of life of that lamp, your image quality, the brightness, etc., is going to go down. Then you need to replace it or call your integrator to have it replaced. And it's all that hassle. And, it just happens to be Friday night, 8 p.m. and you want to start watching a movie and you're just like, oh, shit, I should have replaced the light bulb or have it replaced, all of that sort of stuff. So it's, again, that comes back to convenience that you want to have. So, like I said, evolving technologies, monitoring how they evolve, how they perform. So we think it's going to be a mixture of either a full laser or LED or some sort of other applications, or how should I say, maybe manipulations to the different technologies, because there's all sorts of stuff you can do, right, with chipsets becoming more and more powerful. So that is, but lamp indeed, like you say, that's going away over the longer term, we think.
And the Bragi's unique in your lineup because this is using the LED technology. So it's sort of like a baby version of the Thor in a way. I probably shouldn't compare it at all to the Thor, but it's got 3 individual light engines, a red, blue, and a green. At least it's similar on that front, right? So is the LED, does that help give more color range, or is it? I mean, I know there's some some benefits straight up with the fact that it must run a bit cooler because it's definitely a quieter and a smaller unit to the Bauer model, which is it's kind of neat. So yeah, tell us a little bit more about that technology and how that's working well for you guys.
And just the way that light is generated by LED illumination and the way it is processed by our eyes and effectively our brains in the end means you're going to be perceiving it as a more punchier image. It's going to be perceived also as a brighter image, 25% higher than it actually is on the screen, or the specs on the paper tell you it is. So all of that combines with how we are perceiving it, and why a lot of people, you're not the first actually to comment on the fact that it looks like a baby Thor, so to speak. So yeah, I mean,
cool. It's got merit.
Yeah, it definitely has. So, I mean, again, looking at, like we said, we think the cinematic experience starts at 3 meters wide, and with the Bragi Cinemascope, we wanted to address a question that we kept getting in the market, which was, we would love it if you guys have something that would start at that screen width and price point, but still have amazing image performance in all areas: brightness, color accuracy, etc., etc.
Yeah, it absolutely nails it. And I found, around 3.4 meters of width seems to be easily push the Bragi up to that with a reasonable gain screen.
Yeah.
I've even used a woven screen, 3.4 meters with the Bragi, and it is super dynamic, really crisp. And actually, we did a photo shoot the other day. I'll have to share the images. We got some really great pictures of the Bragi in action. A little bit of steam under the beam gave us a bit of effect. And we went to a few different projects that day, and not every project that day had Barcos in them. And on the other jobs, I was we had the Apple TV display up often between them. So we had a reference source between each one, and I'm like, and I've got the menu up on the other project. I've mentioned a few brands during this conversation, but I won't this time. So I got the other brand up there, and I'm like, got the focus out. I'm like, there must be more in this. And that was it, right? So it's just because I came straight from a Bragi job, a Barco job, into the other job, and I'm like, what's wrong with this thing? So yeah, it was quite a stark difference, though. Yeah, even at 3.4 meters, the Bragi really lights up. We had another one at closer to 3.7 meters. That starts. It's interesting as you think that little bit more, but there's a lot more surface area going on. It's kind of exponential surface area. So we actually specified the Bragi. Then in the excitement that we then upgraded the screen. And we also upgraded a whole bunch of other things, which was a lot of fun. We're like, well, if we're going to change the front stage, let's look at different speakers as well. So this job's become a lot of fun. Though, and you know who you are, because I know he's going to be watching this. So we went the bigger screen. We went from I think it was about 3.3, 3.4 meter screen already there to 3.almost 7 scope. Once the Bragi came in, it was beautiful, but I went, I think we might have actually underdone it for light output in the end. And we actually ended up upgrading that job into the Bauer, which the client was happy to do, because we sort of gave him the report that in our excitement we've gained more size, we got color, we got all these cool things, and it looked amazing. Though we actually didn't have the light, and that was important for him. So we actually ended up going for the Bauer model, and it really lit that screen up. And so it's cool that there's a product range there specific to the application. And of course, for projects that don't need so much screen size, you save a lot of money getting a more efficient light engine, which is in the Bragi. The value proposition of that model is just amazing.
That's great to hear, actually, Scott, because it goes back to what we sometimes get asked about, and that question is then, what is the best projector that you have? And the answer is, well, what is the room that you're looking for? Are you looking for a 16:9 screen in a media room application with ambient light flooding it? In that case, a Balder 16:9 or even Medea or a Loki 16:9, depending again on the screen size, that'll be the right projector for that job. Whereas if you're talking, I want to do a 5.5 meter wide Cinemascope screen, well, don't go looking anywhere below Loki Cinemascope, because you're just not going to be satisfied with what you end up watching on that screen. So it's the right projector for the right kind of project, we would say, not exactly what is the best.
Indeed, and even within a particular model, you guys can customize the color wheel, or these three options within, you know, the laser phosphor sort of range. So yeah, I mean, yeah, and that leads us to Loki, which I haven't installed one of those just yet, though I'd imagine very much like the Bowder and the Bragi, just, you know, a bit bigger unit again, and of course more light output. So, and I guess the Bowder really probably taps out at what sort of screen width would the Bowder start to lose its punch? Probably around 4.5 meter, I guess.
It depends on the color wheel that you've got installed, but yeah, I would say 4 meters is kind of that threshold between transitioning from a Boulder into a Loki. And really the key difference between the Boulder and the Loki is the illumination system. So the Loki doubles up on the number of laser arrays within the projector. And then of course, because of that, it's a larger chassis unit because we've got additional cooling that goes alongside that. But besides that, they're effectively the same product. We're just increasing the horsepower.
Yeah, because the chipsets, I'd imagine, I mean, they're all they're CS capable if you choose that option, and the lenses are all the same for those three models. So that's what, yeah.
Correct. Yeah, it really does come down to the illumination, and in tandem with that, as I say, the heat management of the projector.
Yeah. So it's all about horsepower. I think it's the Bugatti, which has like 16 intercoolers throughout that machine over various elements, which is what happens when you start throwing 1,000 horsepower into a motor vehicle. You know, there's more involved. So, and look, that's probably a good point as well. I mentioned to people, you know, like they'll ask what size screen should I have? It's like, well, where are you sitting? Or an even better question, how many people do you need to serve in this room? Or an even better question is, how many people do you need to serve in this room at once, regularly?
Yeah.
Because I see people sometimes put way more seats in than they have to, which compromises the seats that are really important to them. And, you know, they can either do that and with ideally get all the right horsepower they need to deliver the job, or what's a shame is the budget really doesn't push to those sorts of massive screens or massive rooms. So it's like, well, if it's really you and your spouse and a few kids, and you might entertain every so often, if you do go a few less seats and you scale back the room a little bit, you can afford to put in the right products to hit reference SPL levels for sound quality, and you know, good 40-foot Lamberts with P3 color. You know, you don't need a 6 meter wide screen when maybe a 3.5 meter wide screen actually is what they need, and they can nail that experience. So it's another way of scaling someone's, I guess, budget to a degree, but scaling how we can still deliver an experience by you know, changing the way we build the system. A number of seats, yeah, that's, you know, there's a reason why two-door sports cars perform so well. They have to worry about less people, you know. Yeah.
Yeah, exactly. It's very true. It's looking at how the cinema is going to be used on the regular, not just for when all of the extended family comes over, you know, Christmas or Thanksgiving or, you know, Easter, etc. You know, because they're those 2 or 3 time a year scenarios where, you know, theoretically you could put the kids on beanbags in the front row and they'd probably like it equally as much as if you just had that extra row, you know?
Yeah, I've been relegated to beanbag a few times. It depends on our visitors as to if I lose my middle seat or primary seats. But it's great fun. You know, you still have a lot of fun with the sound and picture. And another element as well, I find, because of course we don't like our seats on near walls or on the back wall. We like our seats off the wall a little bit. Usually, you know, we can get maybe 1 meter behind the back seats typically. And, you know, if they want another row of seats, we'll bring the kitchen bar stools or the alfresco bar stools. They've space for them behind the primary recliners. And, you know, you can usually get 3 bar stools, per every 2 primary, seats. So you can end up with, behind a row of 4 primary seats, being, nice recliners, you can maybe get 6 bar stools sitting back there, and you can get another 4 to 6 people in the front areas, and then 4 people in the primary row, and you've literally over tripled your capacity of your cinema room for the big game, which happens a couple of times a year. And then you really just repurpose the seating. The primary row doesn't have to change, and then on the Friday night or a Monday night, or just whenever your family enjoys a show, it's in 2-door sports mode, really the whole time. And you just throw the trailer on the back when you really have to. But so that's I just share that because as people are like, oh yeah, how can I do things differently? And you go, oh well, less seats, but I really want to be able to entertain. And that's just a really popular way I find that people manage to have their cake and eat it too still.
Yeah, it's like Bart mentioned earlier, it's that return on experience. That experience is going to be of a higher quality because you've designed it for your day-to-day viewing, not the occasional viewing. Yes, your occasional viewing will be marginally compromised, but as I say, that's 2-3 times a year.
Exactly, and it's a shame when we see primary viewing compromised full-time for the maybe times.
Correct.
Yeah, 100%. So awesome. So we chat a little bit about color, and I mixed into that in the end dynamics. We talked about what it takes to get projection really taking advantage of the HDR technology, which is cool. A little spin off the dynamics is contrast. We did talk about it. We didn't maybe go too deep into it. Dynamics being really the perceived contrast of the room. So it's not just light output, but the ability to create, no light or black. So, and be able to do all that in one frame as well. So tell us a little bit about ANSI contrast, which is the metric you guys are going for. What is ANSI contrast?
Yeah, of course. So there are different ways of measuring contrasts, and typically what other manufacturers will measure will be either sequential or dynamic contrast, which is more often than not where you display full frame white and then full frame black, and then obviously calculate your contrast figures from there. And historically we've seen values, it used to be 100,000 to 1 was big. We're now up to infinity to 1. And not quite sure where we'll go beyond that.
It's a very interesting infinity to 1. I think only what's his name, Lightyear from Toy Story. He's the only one that can go to infinity and beyond, right?
Indeed. But they're kind of false contrast figures because you're basically looking at just a full black frame and a full white frame, and of course that isn't how we view content.
Never happens. Yeah.
Indeed, exactly. So what ANSI contrast does is it takes a number of measurement points across the screen using a special test pattern. So it's a checkerboard test pattern. So we're displaying both black and white at the same time, which is far more representative of how we view content. And of course, because we're taking multiple measurement points across the screen, we're also compensating for uniformity as well, because of course the corners versus the center of the screen, there'll be a differential. So it's a far more accurate way of measuring your contrast and then relating that to how it will perform in the real world environment. And typically speaking, to give you an idea, as I say, I've thrown out figures of 100,000 to 1 and even an infinity to 1. Our Boulder and our Loki projectors and likewise the Bragi, our ANSI contrast readings, we measure at 450 to 1. So those figures, look absolutely minuscule when you compare them on paper, but it's a much more representative way of what you will actually achieve in your theatre.
Mm-hmm. Okay. So these... not a lot of manufacturers. So you guys do give numbers on ANSI contrast, which I've seen. There's not a lot of manufacturers that actually do that. I guess if they would, then it starts to expose the reality of their numbers. So they choose. And look, we know that there's plenty of marketing companies that are leading, obviously, the presentation of products to the consumer, and even to the industry. And these a lot of the industry aren't as educated as they could be. And they also are looking at what's the impressive numbers and things I can say to sell a product rather than to engineer an experience, which is what we're talking about here. What sort of ANSI contrast are we getting in something like, I don't know, the Thor, which is AKA the big baddest one, or the Thor Plus? Let's go all the way. I haven't looked at this. I haven't heard much about the Thor Plus, but I'm just going to guess it's that little bit better.
So with the Thor, it's 1,000 to 1. With the Thor Plus, it doesn't increase hugely. It's 1,100 to 1.
Okay.
That in itself is actually a big step in ANSI contrast. And the whole purpose of this as well is that we want to be able to display detail within black, not just display everything that's black within the content as an oil slick. Where there's no detail in it, it's just everything turns to black. So looking at the diffuser on your wall behind you, for example, it would be very, very easy to, on a projection setup, to actually lose all of the detail within that, where the light's hitting it and you're getting different shades of black and grey and what have you, and for that just to look like the wall to your right-hand side.
Yes.
Whereas on a projection system with very good ANSI contrast, you can start to really, really pick up those different detail levels within the black. It isn't just showing, as I say, that oil slick black where all of the detail's lost.
Mm. So that's both that's all 6 parts of the picture puzzle to be able to deliver great ANSI contrast. So we can't go back and pick on one or the other, though. An element to this, though, which some people might not think of, and I've seen this in as we calibrate, and sometimes we put separate video processors on other units to try and give them some extra, say, calibration ability. What I've also seen is the digital black. So calibrating, where does black start in the signal for the optical system to then start displaying it. And that, and in some units you kind of go, okay, I'm going to up the brightness here, and you kind of go from nothing to something to a lot, and you kind of, well, where's the middle ground? There must be something along the way here. And of the Barco, it's got like, what is it now? I think it's over 100, maybe 200 points of scale when you move the slider.
Yeah, I think you've pretty much got 100 in each direction.
100 inch, yeah, because I think it's 0 in the middle and it's negative and one all the way to the right.
0 to 1. It changes on brightness and contrast. I've never quite actually understood why.
Yeah.
We go 0 to 1 and -1 from inch of 0.100.
Yeah, 0.100. So we sort of go through and dialing it. And of course, again, the room plays a massive role as to where that needs to start. So, but yeah, we're just getting that beautiful detail out of the image. And again, Gemini Man was a phenomenal scene where it was one of almost the whole video was just amazing, right? So pity about the script, that guy didn't hold up his end of the bargain, I don't think. But that's more subjective. I think very objectively we can say that the resulting picture was absolutely spectacular. And you have the frame rate, you have the color, and then you have the ANSI, the dynamics on there, and the thing is just extraordinary. So that's certainly something I'd be urging the listeners and the viewers out there to check out one of these Barco installations. And if it's a showroom or a dealer showroom, then particularly check out. They'll be crazy not to show it off because it does such justice. The Gemini Man, so you can see all these elements really start to come together, which is super cool. So ANSI, I'll just touch on contrast one more time, is as we see the other brands play their tricks with even the projector off or I think the lens and the iris completely shut down as black and then completely wide open as white is another trick. It's almost like saying that your car does a quarter a mile in 9 seconds, though that was going downhill. They didn't mention that part. It gave, or it's like, oh, it does it this quick, but it was a rolling start. These lots of silly tricks that they play, but ANSI seems to be the more of a real world figure and a more even playing field. I do see that pattern come up in the calibration software, and I've been meaning to actually do my own measurements on the white space and the black space on ANSI as we do, so I can get a few more of my own data along the way and help to more accurately design projects as well. Some people appreciate that science. So the other element with I guess how we look at great picture from the calibrator's side is frame rate, which of course we've come up a few times with Gemini Man. Now cinema is usually 24 frames, or is 24 frames per second, thereabouts, 23.976.
Yeah.
76, yeah. Which is the film reel spinning through the camera and clicking away. So it's which we used to be used to. That's the past now. So and even in digital, the digital camera systems are typically 24 frame as well, I believe, and therefore the Ultra Blu-rays and Blu-rays typically that. Though the systems, most projection systems, particularly you guys, you can do 60 frames per second.
Yeah.
You could have the screen potentially flash 60 times per second, but you've only got 24 frames to work on, so that's an algorithm that needs to be worked out. Is that true? Is the picture running? I guess the flashing rate's a whole other game, because DLP chips are literally blasting away multiple times here. How would you explain frame rate? How 24 frames is actually displayed on a system compared to a native 60 frames displaying on one of the systems?
So the way we do it at the moment is we stay true to Hollywood's intent. So Bart alluded to it earlier, there's a public broadcast, as it were, that Tom Cruise was a part of, saying about turning off motion smoothing, motion blur, frame interpolation, name it as you wish.
300 hertz motion mastering.
Exactly. It's got lots of different names depending on the TV or projector that you're looking at. And as I say, we at present stay true to the director's intent, and we actually don't have any form of that within our projector. So when we're playing movie content from Blu-ray disc or UHD Blu-ray, it will be displayed at 24 frames a second, unless, of course, you've got one of the rare discs like Billy Lynn's Halftime Walk, that I think you get 24 frames and 60 frames with it. I must admit, I don't know how the UHD Blu-ray release at present of Gemini Man is, whether it's 24 frames or 60. I haven't looked at what
Interestingly, the Blu-ray disc or the 4K UHD disc is 60. Kaleidescape version at present is the 24 one.
Oh, wow.
That doesn't surprise me to hear, because I know with Billy Lynn's Halftime Walk, Kaleidescape initially was 24 frames and then they added the 60 frames. So we would play it as delivered by the content. So obviously when we're watching movies, 99.9% of the time it's going to be 24 frames a second, and then when you change over to sports, gaming, the soap opera, whatever it might be, it's typically going to be 60 frames a second.
Okay, yeah. And these, obviously the gaming world is pushing for more frames, these talk of 120 hertz and these sorts of things, which doesn't really impact the cinema experience, because we got 2 movies, if we're lucky, depending on the release, that even does 60. Though it is a beautiful thing that happens when we get that frame rate. So really, we've kind of, for cinema at home, we're sitting on top of the perch right now as far as frame rate goes. We just want more studios to give us the goods, or to literally create content in a higher format. There's nowhere to go at the moment other than waiting for more good stuff to come. Yeah.
That's exactly it. I think there's always been that reluctance from Hollywood, it seems, to push frame rate, perhaps with the exception of one or two directors. And I think that's partly because of nostalgia. There are a lot of directors that like that cinematic effect that 24 frames gave. I think also, actually, you touched upon it ever so slightly earlier, is that visceral experience as well. Sometimes that higher frame rate, although makes the image look considerably better, and actually, in my opinion, increasing the frame rate is actually far more noticeable than what we will see going from 4K to 8K, for example. But I think for some viewers it's almost too visceral. If you're watching a horror movie, for example, I think people like the fact that it's 24 frames because it has that film like look, and as a result your brain is in, okay, although I want to have that suspension of disbelief, I'm watching a movie, it's not real. Whereas at 60 frames a second or 48, whatever you want to do, sometimes it can almost be, no, this is too real. And I think that's also possibly partly a reason why studios aren't going to that, besides obviously just the production cost as well. That's a key thing for them. It's more expensive to produce.
Because you've got, literally 2.5-ish times the amount of frames to master and make sure they're in the right place, right?
And render the visual effects for,
it's
CGI, wow,
I mean, with the CGI, it's Gemini Man is a prime example of that. The film's content looks amazing, but actually a lot of the CGI scenes in it and the special effects, you look at and think, okay, you can really notice it, they almost stand out from the content. So that's a challenge as well. So it will be interesting to see how and where Hollywood develops. I realistically can't see them jumping to 8K quickly, but hopefully they'll start to push frame rate a little bit. Hobbit for me was a good example at 48 frames a second. That wasn't quite as visceral as the 60 frames of Billy Lynn and Gemini Man, but still notably better in terms of image quality than 24 frames.
100%. It's interesting with, as you say, the cost and the care required with more frames. I guess it means that these sort of nowhere or less places to hide as a producer or director. You can hide a few things between a few frames here and there, but at 60 hertz, you're seeing more often. So you've got to make sure it all counts. And then, as you say, the CGI is a challenge. So, cost obviously a big element, but picture quality amazing. And you've mentioned 8K a few times, and we all, I think, kind of in this, hopefully in this space, we chuckle a little bit at it because we know if Samsung produces an 8K TV, well, LG's right up there to do the same thing, and they're out there battling each other on specs and numbers. Whereas what is the realistic benefit? It takes, I think they were saying it takes up to almost the 45-degree horizontal viewing angle for the audience to start to actually discern between 2K and 4K anyway. And we know that most people aren't getting that screen size unless they have a beautiful big Cinemascope Barco at home, which means that 4K surely has taken us all the way up to 60-degree viewing angles, which are usually about as big as we go. I have a lot of. I'm still a big fan on the installs that we've done that. I'm a front rower, 60 degrees, bring it on. I love it. Not everyone in that family would do that. They'll sit at the back and they're more back at that 45-degree viewing angle, which is cool. It is subjective screen size. Though if you can't resolve an 8K pixel inside the realistic screen sizes we're in, if the lens systems are going to muff it up anyway, then what's the point? And I guess, with TVs in particular, if you're 5 meters away from an 85-inch TV that's 8K, you're not resolving, I believe, the 4K pixel resolution anyways. Is that sort of a fundamental reason why it's a bit silly, as well as the fact that there's more costs of production, cost of bandwidth, cost of hardware, and then the fact that we can get better picture by increasing color or frame rate anyway. So it's like these better stuff sitting on the table to not chase 8K. Yeah, I'll let you guys
pretty
sort of
much.
expand.
I mean, I think Hollywood is sensible in as much as they appreciate the cost of creating content, etc. And they're not chasing that 8K dream. It's they are looking at factors like frame rate, etc., that are ways of increasing image quality, which still increase production costs, but in different ways. It really is the flat panel manufacturers that are driving that 4K to 8K, and we've got to have the content to deliver to those devices, which means we need whatever the next derivative of physical media is, if there is going to be an 8K physical media, if there is or isn't, and we're going to be delivering it through Netflix or otherwise. We need to find a way of getting it down our pipe to the house and in an uncompressed format. Otherwise, we really are taking a backward step, and we may as well have just stayed at 4K. Yeah, I can see the desire and need to push towards that eventually, but I wish we take a step back and look at the fundamentals and actually deliver on those first, even if that requires higher bandwidth in itself to do. But do the sensible thing and address those.
Yeah, indeed. So there's a lot lower hanging fruit just on even compression methods. If Netflix go, all right, well, we'll have another algorithm. It could be Ultra HD Plus, or I'm sure they won't confuse people by changing things. They'll still label it as all the glory. And in the back end, if we can get 30 to 50 megabits a second, which is starting to become a bit more of a normal bandwidth in Australia now on a good day. Thank goodness. And it's like, hey, let's pump it through that. Let's use that 50 megabits per second and fill up 4K rather than doing something silly and say it's the 8K version and just compress the shit out of it anyway. Doesn't make a lot of sense. Yeah. I've actually we've covered some really cool stuff. And I know I've had you guys for almost maybe a couple of hours now. I can't believe it. I look at the time and go, that's cruising by. It's always cool when it's something which is, we're passionate about it and excited, and it's really at the forefront of what can be delivered for people. I got one extra special question actually for you guys, because I was asked this by a client a little while ago. It is actually the example of the 3.7 meter wide screen with a Belder. The question was, what would I get? What would be the difference if I put a Loki in here? And I do know that because we'd have horsepower or luminance up our sleeve, we could actually start to do more accurate color calibration. We can start to get the color engines and accuracy even more dialed in. And there's only one way you can do that, and that's taking away, not putting in. Obviously the HDR performance is there, and then there's also potentially, we could shut down the iris a little bit to increase even more contrast as well. And it's all kind of hugely, in a way, inefficient. It's like we're throwing more horsepower in to then just take away from it to just try and extend what we're left with dynamically. So there's some technical things I felt were capable and would give an advantage, though you guys would have seen this, no doubt. I haven't. What would a Loki look like on a sub 4 meter screen? Is that thing just like a little bit not required, or is it like, man, if you can do that, then you're on cloud 9? What do you guys think?
Well, I think you've touched on it pretty perfectly, to be fair. I mean, the additional light output allows you to calibrate the colors more accurately and obviously use that DCI color wheel to its full potential. It also means that when we're watching HDR content, because we've got that additional brightness, we can ensure we're hitting that 40-foot Lamberts, which means that our spectral highlights, as and when we need them in HDR, are really gonna pop. One thing to pick up on is you mentioned the iris. So actually the Loki doesn't use an iris. So the Bragi and the Boulder do, but the Loki, because of its light output, actually doesn't have an iris. But we can adjust the laser intensity, like we can on the other models too, so that if we're watching SDR content, we can reduce that headroom, as it were, so that our SDR content looks as good as it can, and then ramp it up for our HDR content. And again, that will help us with contrast levels and what have you too. So it really is just pushing that extra brightness in colors and the benefit from the spectral highlights of HDR. Besides that, as I mentioned earlier, that the lenses and fundamentally the mechanics of the projector are more or less the same. So it's getting that extra punch from it.
Cool. Yeah, it's kind of interesting. You could obviously throw quite a bit more cash in just for those few times you have that glisten off the windscreen, and it's like, amazing, though it's you need all of that power there for those little bits. So
it's subtle nuances. It's if you've got the disposable income where comparatively the jump from a boulder to a Loki is relatively small, hey, it makes sense to do it. But if a boulder is the top end of your budget, arguably jumping to the Loki, yes, it will give you a performance increase, but it may not give you that same value for money as perhaps other upgrades may.
Yeah, because we already hit target on the main things we needed, really. So it's a little bit like a sound system that can play at 120 dB. It's like, well, it's like, yeah, you could do that, I guess. So what do you think, Bart? Have you seen the Loki on a smaller screen? How does that punch out?
I would have to agree with what Andy is mentioning. I mean, it's nice to have that extra horsepower on top, that headroom, because it basically comes down to headroom, right? I mean, it's always nice, I think, to have headroom. And like you say, you can take out of a system, but you cannot add what is not there to begin with. So, yeah, if budget permits, it would be nice to be able to go that extra mile for sure.
Actually, an idea would be even, now I typically use white screens. We're in dedicated cinemas and, we get a great color, best we can get out of that typically. What about other than in ambient light conditions, still dedicated cinema, we're running a grayish screen, if that's the right term. They'll cost the projection system effectively light output returning to the because usually they're a 0.8 gain. Would that then give us even better dynamics with contrast because we're going to get a deeper black? Would that be another approach of just trying to really push and expand the system to gain contrast in that way? Because you go, well, we've got the horsepower, we can burn 20% of our light by going to 0.8 gain screen, but still hit 40 to 50 foot lambits. And now, though, we've got a little bit deeper black, that might be increase our ANSI as well. Is that a strategy or a technique you guys have seen before, or are you sort of leaning away from the grey screen concept? And
certainly have seen that before. It can be a double-edged sword in as much as obviously, yes, you can improve your black levels, but inevitably it also pulls down your peak brightness too. And it can push your white point, albeit you can calibrate for that. It depends on how the surface of the screen is made up to. So again, you want to ensure that it's not going to have an impact on your uniformity in any way, or your off-axis viewing, which is, to be fair, that's more of an issue when you go to a higher gain screen. So typically speaking, we're fans of unity gain screens, perfect Lambertian screens where possible. They will give the best image quality you can get. So I would say, for me, specifying the right projector with the right screen surface rather than play around with the screen surface too much. Certain screen surfaces do have their applications, ambient light rejecting screens in ambient light conditions. Yeah. But for a dedicated theatre, for me, I'd say, stick to something around a gain of 1 if you can, or as close to, I know acoustically transparent screens, they'll possibly be like 0.95, for example.
Yeah, we've got a little bit of stuff which is sort of claiming even a little bit over 1 with a woven, but I think realistically we're still very close to 1. But it sounds like we're doing everything right already, so that's good feedback. And as I say, it was kind of like sort of trying to hack at the system of trying to increase a few elements by really pretty inefficient way of going about it, by just burning horsepower to just grind out the last little details. But we've been absolutely thrilled with the performance that we've been doing at the Rogues Home Cinema team over here. I think, guys, you've been really generous with your time and feedback today. So I got dinner to head to. You guys, I think, are maybe just looking at lunch. So I appreciate the fact that you guys have dialed in from the other side of the world. Is there any sort of lasting elements that either of you would like to touch on as we finish up?
Well, first of all, thank you for having us, Scott. I mean, it's been our pleasure spending time with you. I would say anyone's interested to have a demo, I would invite them to get in touch with either you or, depending where they are, with one of their local integration partners. And if they have more questions, you can always visit www.barcoresidential.com. And yeah, any questions, again, either through you guys or via us directly, we'll be glad to help everyone along.
Awesome. Thanks, Bart.
You're very welcome.
Yeah, and likewise from my side, nothing to add. I think we've covered a heck of a lot during the couple of hours. So just a thank you, Scott, to you, and likewise to your viewers.
Awesome. Yeah, well, we've certainly getting a great following of people that really appreciate that professional, real cinema aspect. You know, the home theater thing is sort of some stuff in a room versus a calculated and considered project, really transforming a room into something special. And if it isn't for leading products and brands such as the team, you guys at Barco, that are really cutting edge on that. So I know there's not many can start to comment on the differences and the elements and the approach that Barco have. And again, I would also, you know, if this has sparked some interest and curiosity, Evan, definitely check out one of the cinema houses with a leading Barco projection powering it up, or a specialist home cinema integrator that has the ability to demo it, because the picture truly is 1,000 words, and at 60 frames you could say it's a good sort of 6,000 or so words. So guys, thanks very much. Really appreciate it.
Thank you.
We'll definitely check in with you guys maybe in the future as other things develop and evolve. Then I really want to keep all of our audience across everything, so they can see where they can set their goals for either upgrading their cinema, or there's plenty of guys and folks out there who, you know, different stages at life. At different times you invest into things, you know. There's certainly a stage of life where that two-door sports car might come into it. And there's also, you know, when the hi-fi speakers get packed away, because kids like to poke those things. And, you know, moving or renovating a house is a big deal. And I know these people out there that are like, when I make this next move, it's go time for that room. And these podcasts and these interviews and conversations, I think, really help guide people into that bigger concept. So when they do get the chance and the luxury of making this happen, they can really invest into that and get a really great return on experience. So once again, guys, thank you very much.
Thank you, Scott.
Wow. So my big takeaway there was how Barco work with mission critical projects, and how the system resolution is how you get every pixel just right on the screen. Even better, the fact that Barco Residential have all those attributes, not just their commercial counterparts. So guys, to stay all across everything professional and real cinema in your own home, remember to subscribe and check out our website for more inspiration and services. Remember, with great home cinema on any day, reality can go rogue.